Then I have the pleasure to announce the next speaker, Sebastian Wernli. Sebastian is a research associate at Hochschule München, University of Applied Sciences in Munich, where he works on evaluating reclaimed window glazing for reuse and remanufacturing, where he also performs his PhD on that topic, right? So no surprise that also that will be the topic of today's presentation on circular IGUs. Sebastian.
All right, thank you. First, I want to have a little disclaimer. I'm going to present in the beginning a little bit about the problem that we're talking here now, and I'm talking a bit about numbers, and they are mostly applied to Germany alone, but it's not a very complex issue, so the numbers are very similar in other countries in Europe as well. At least the ratio is, and the problem is, as we saw yesterday, is occurring in other European and international countries in general as well. I'm going to talk first about the problem and the scale of it. This is one solution to regain material or not. I think we all agree that this is probably, in terms of circularity for glass, the worst thing that we can do. Luckily, it's not the biggest way we do it right now anymore. This is, short video. This is probably the more common solution right now, extracting the windows before a building gets demolished, and more so even the modernization of buildings, rechanging the glazing or the windows. Yet it comes with some obstacles and issues as well. I don't know about you, yesterday there was a talk about developing sort of an empathy for glass, and doing a lot of research on reusing and circular strategies. I think this always hurts a little bit, at least to me. I don't know about you. If a glass like this just gets thrown into a container and ends up like this, shattered, although to me it looked at least something that we could look into for reusing or remanufacturing. So this is where it all ends up, a big pile of glass waste that's getting recycled somehow, mostly downcycled actually, so only in Germany from almost 500,000 tons, 74% of that is post-consumer glass, only 12% of the total amount that's collected, so pre- and post-consumer glass, is actually recycled to float glass. Most of it is downcycled, completely leaving the closed-loop cycle of float glass, so there's a need for constant virgin material extraction. So this is the problem that we're talking about. In Germany, 350,000 tons of post-consumer cullet is collected every year from demolition and modernization. Yet, if you only look at flat glass, it's still mostly linear. So you could raise the question, why is that? Glass seems to be 100% circular, very good material to actually develop circular strategies, but yet it's not happening yet. I sometimes get the question, well, glass is just a niche product. If you look at other materials, that's much more impact there. Well, it's actually not the case. The only one that's higher in impact is concrete, and that's just because of the sheer mass that we use. But architectural glass is actually a large contributor to greenhouse gas emissions in the building construction, so it's always a matter of perspective and scope. And if you look at the building construction, glass is actually 1/3 of concrete, which I, for myself, think is quite a big number. And if you look at windows, doors, and glass combined, it's actually number 2 of the most impactful materials altogether. And that's because glass has, per ton, a much higher impact than concrete, for example. It's 10 times more compared to concrete, and I think that's making it quite relevant in the question on embodied carbon. So, I was talking about it earlier, there's a material hunger, which comes also with a dependency on fossil fuels most of the time, the constant need for virgin material extraction, as you can see here, which comes with a massive impact on the environment as well. But I also want to highlight the loss of value that's happening across the supply chain. So, cullet obviously is worth much less when you shatter it, the glass, compared to a glass pane that's still intact. It's quite obvious, in my opinion. So it's not only an ecological problem, but it increasingly becomes an economic issue as well, especially with rising energy prices and fragile supply chains when it comes to raw materials. So to take it to the extreme, I'm aware that this is probably not what it looks like for glass, but I wanted to highlight that if it's not working for glass, which other materials is it going to work for circularity? So I think glass is a perfect example that can be upfront in the terms of developing a circular economy. And if it's not working for glass, how it's going to work for everything else. Just wanted to point that out. Essentially, we're mining mountains just to pile them up somewhere else as waste, and I think that's not the solution in the end. And I think we as the glass industry should go forward and show how it's done differently. Well, enough about the problem. What did we do in the research project, or are doing? It's still going on for one more year. At first, we looked at standards, requirements for testing glass in different configurations, but we also looked at the current building stock, and that followed a lot of experimental testing to kind of figure out what's the best strategy to implement different circular strategies. So we looked at different configurations of the glass, but I'm going to talk about that more in a second. And then we were trying to develop an effective testing procedure that finds out at a very early stage which circular strategy we can apply to certain glass that we reclaim from the current building stock. Talking a little bit more about the utilizing existing potentials. I just said we looked at the current building stocks, so these are the numbers for Germany. You can see there's right now almost 600 million windows installed in Germany, and the most part of that is actually double IGUs that are coated. But I think a significant amount as well is the 168 million windows that are double IGUs where no coating is applied. So those are actually the windows, and the vast majority of it, which is worth renovating in the next couple years. Also, a part of the blue column obviously is also worth replacing and is getting replaced, especially the ones that were installed in the early 1990s. But I think the biggest question that's coming up in the next couple of years is what happens to the uncoated double IGUs. I'm not going to go into much of detail in that. That's going to be covered in the publication as well. I know there's a lot going on here, but as you can see here, the float process, for example, just wanted to highlight a couple of things, was introduced in 1959, and we tried to compare that to a couple of developments in the standardization. And float glass in Germany actually didn't find its way to the standards until 1980. So before that, I think there was obviously the biggest shift in the glass production was the introduction of the float process, but it took quite some time to develop standards for this, and it actually became the norm before it was put in the standard. So I wanted to highlight that looking at the standards and always applying to those might not always be the solution, especially for circularity, just because it takes a lot of time, and I guess we don't have that anymore. So what did we do in the project? We went to a couple of different buildings, and we started with sourcing reclaimed IGUs, old IGUs from buildings. This is the one in Frankfurt, an old office building that's getting refurbished to a school. Here you can see how we did the audit. We looked at the glass composition, the general visual inspection, and we also put a sticker on each of the glass so we can refer to the location and all the information we collected further on after it was transported to the laboratory. There's also a second building that we looked at, which is in Berlin. That's actually part of an innovative project. This building is getting refurbished as well, modernized energetically, and we were part of the technical evaluation of those windows as well. And I'm just going to compare a little bit those two findings from those two buildings, because the IGUs were actually from a very similar age, but we had very different results, as you can see later on. We did some gas fill and dew point measurements, especially here you can see the measuring argon content, and we also checked for the presence of SF6. I think that's a raising issue coming up it was used in the sound insulation applications, and the right measurement device is actually for SF6. In this case, for the Frankfurt ones, we didn't find any gas fill. For the Berlin IGUs, that looked differently. We also looked at the secondary sealant, so through spectroscopy, we identified the material that was used, because that's important for a later compatibility if you want to remanufacture glass into new IGUs, for example. The compatibility plays a major role, and not all sealant materials are compatible with each other. For that, as you can see on the left picture, we also separated the IGUs manually. Yesterday we saw there's also mechanical ways to do so. A big part of our research is the visual quality. I think that's a uncertain topic right now. No one's really knowing how to handle the visual quality compared to the strength as well. So all the IGUs from Frankfurt, we try to simulate, according to the standard, the situation in situ. So you can see here on the left, we put it in an open window frame and took some distance and looked at it with the regular background that you see in the normal building situation. But we also applied the standard that's mostly used, or the situation that's mostly used for float glass in the production. On the right, you can see the kind of document that we use to mark all the defects that we saw in certain stages, and also we had a look in more detail to the glass to kind of identify all the mistakes that we can found in this setting. However, that wasn't enough for us. We also built this lighting box with a black background, so you can actually see all the defects, the surface scratches on the glass much better. We highlighted those with a glass marker in white, and then afterwards used a scanner technology as well to kind of compare the results from the manual inspection, so what you can see with your bare eye and what the scanner actually sees. This is a scan from one IGU from Berlin. You see there's not that many marks on there after all. On the right side, you can see a close-up of some of the scratches we identified in the light box. And the scanner actually didn't even pick up all of the light scratches that we saw in the box. So we're talking mostly about very thin, very light scratches, often not the ones that are responsible for a great reduction in strength. To check on that, to prove that, we also did surface testing for strength. You can see here the double ring bending test setup on the left side and a sample on the right side that was, in this case, a valid sample, and it's actually the one that we saw earlier. The two markings are the same. You can see them on the sample, and here again the cracks weren't responsible for the break origin point, as you can see on the right side of the loading ring. Here are the results from the statistical evaluation. We tested the inside and outside surface of the IGU, as you can see on the right side. And we also had a reference series of 6mm new float glass as we received it. And yesterday we saw some graphs for artificially aged glass, which actually behaves quite similar to the outside surface here. So you can see this, the orange curve is much steeper than the other two. The distribution is not as spread out. But the inner surface, the inside pane, actually behaves very similar to the reference glass. Although it actually, the old glass, which was 30 years old, exceeded the strength of the new glass, which was quite interesting. We're going to look further into that, just some very interesting first findings. So to compare the two from Frankfurt and Berlin, once again, manufactured in 1992. The IGU configuration was 4mm of float glass on both panes and a regular spacer width. We have several visual defects on this one in Frankfurt, at least on one surface. So that was also caused by a transport that wasn't quite suitable for reclaimed IGUs. Some of them actually broke as well in the process. But according to the standard, this one didn't qualify. So at least one of the two glasses in the IGU. So There was also no gas fill detected, therefore we didn't even measure the dew point on this one, because it has a U value that's not in the current standards. So it's not really reused as it is, so it qualifies for remanufacturing. At least one of the two paints does, or repurpose. I'm going to say a little bit more about that later on. The polysulfide does play a role for that, so even if one surface is scratched, the other one was still intact, so one could be recycled if it's separated into the individual paints, and the other one could be reassembled to a new IGU. It does look differently for the IGU from Berlin, although it was manufactured in 1993 as well. The IGU configuration was also very similar. In size, it was very similar. It was also a regular window glazing, but we did found a coating actually on the 4mm glass. So the question came up, is it even worth cutting it up and remanufacturing it if the coating is intact? As you can see later on, we didn't even find a lot of visual effects. You saw that in the scan earlier. So it was actually in perfect condition. We did a measurement with a spark-like device and actually found a 96% argon content after 30 years. And that's quite astonishing, I think. Dew point was actually perfect as well. So the calculated and also measured U value of 1.4 makes this one qualify for reuse or at least a refurbishment in terms of upgrading it, for example, to a triple IGU. That's also an option that's considered in this project. Surface strength, we tested it on one, like I showed before, is also fine. Polysulfide, in this case, not as relevant since we don't want to cut it up after all. But that's to complete the comparison of those two. So this whole process of this experimental testing ended up in kind of a flow chart to decide which are the important steps in applying circular strategies. And we think the most crucial part is actually the audit. So collecting a lot of data at site with a little effort. So manufacturer, production date, installment situation, everything you can find without even touching the IGU. Especially what's important is whether the IGU is coated or not. That already implies a lot of different implications for the configuration and the circular strategies implied. If it's not coated, like I said before, it immediately goes to the IGU separation, so reuse is not considered anymore. If it is, it goes further to the visual quality check according to the standard. If that doesn't suit, if that doesn't qualify, you can again separate it. If it does qualify, like the one in Berlin, we go forward to the gas fill testing and dew point testing. If that's both acceptable, you can go ahead and reuse it. If not, it's also separated because the effort would just be too large to try and find the sealant flaws and everything. So we decided the IGUs rather separated. If you try and separate it, the visual quality is also important, of course, but also only on the individual pane. Since it's remanufactured, the individual panes can be checked on flaws individually, and also the secondary sealant should be identified. So there you could remanufacture it with actually the same dimensions and use it in the same location, for example, like in Berlin. But you could also, if one pane, for example, from Frankfurt is not coming up to the standards that we want to in terms of visual quality, one pane could be recycled, closed loop, and the other one could be, for example, trimmed off the edges, or major flaws could be cut away in order to use it in a different location or in a different application with smaller sizes. Our next steps is a large strength series, double ring bending tests. We only did it for the Berlin glass. We also wanted to do it for Frankfurt to just have a larger series to compare to. We want to do long-term climatic tests and also more detailed LCA studies, especially on the remanufacturing process, to kind of have comparison data, especially in terms of the comparison between recycling, remanufacturing, reuse, etc. finally, the acknowledgements. Thank you to all the partners that supported this project so far, and also the funding institutes. Without the project, it wouldn't be realized. And now I can answer some questions. Thank you.